Hello everybody, in this video we are going to talk about how to simplify polynomial expressions, and in the set of series of videos that we're going to be looking at, we are going to talk about how to take two polynomial expressions and be able to add them and subtract them. We'll also know when to multiply polynomials, and then also make sure that all of our answers are written in standard form. Now before we can actually do any of the math and kind of look at some of those practice problems, there's a couple things that we need to talk about that has to do with polynomials. Vocabulary, what standard form looks like for a polynomial, and how can we actually give our polynomial a name based on some of the vocabulary words that we're going to talk about. So let's go ahead and jump into that part before we look at adding, subtracting, and multiplying these polynomials. So the main thing that I want to point out is what actually sets a polynomial apart from some of the other functions that we've been working with. The first thing I want to point out is a polynomial is going to have the same variable throughout the entire expression, but you're going to have a variable with different exponents. Therefore, we can't actually add them together. So if you look on the screen, you're going to see an example of a polynomial. Why is this a polynomial? Well, notice that we have several x's, but this one is x to the 1 power. So if there's nothing there, remember it's an exponent of 1. So we have x to the 1, this one's x to the 2, and this is x to the 3. So they all have the same variable, but they're not like terms because they don't have the same exponent. The other thing that I want to point out about standard form when it comes to polynomials is they have to be written in a very specific order. So if you look at all of your exponents, we always put the one with the highest. All right, so even though a constant isn't necessarily considered a polynomial, it does have a degree. So a degree is going to be the name of the exponent. So when we look at a polynomial, we look at its biggest exponent, and based on the largest exponent, we should be able to tell you what the degree of the polynomial is. And usually that also tells us what the name of the polynomial is. So I've actually already listed the names and given you an example of what that looks like. We're just going to fill in a couple things that we could identify about a polynomial. So the first thing we're going to point out is this isn't really a polynomial, it's just a constant. But if they were to ask you the degree of a constant, then we can just say that the degree, because this represents the highest exponent, is 0. And we usually don't write exponents, a variable with an exponent to the 0 power. We always cross it out, we eliminate it, and that's the reason why we don't see that variable for number 5. All right, a linear function would be considered linear because it does have an exponent, but the highest degree is 1. So we're going to say a degree of 1. So we're always looking at the variable and the variable with the highest exponent. Now, there's another word that we're going to talk about, which is the leading coefficient. So the leading coefficient is actually the number that's attached to the variable with the highest exponent. So in this case, here's my variable. The highest exponent is 1. This 2 right here in the front is actually our leading coefficient. So I'm going to write it out once, but because leading coefficient can get a little tiring if we're writing it over and over, then we'll abbreviate it in the next one. So let me write this one out first. All right, so the degree is the highest exponent, which is a 1. And then our leading coefficient is going to be the number attached to the variable with the highest exponent. So in this case, it's the 2. But when we start looking at quadratics, we have more numbers, we have more exponents. So for this one, notice that they all have x's, but the highest exponent is a 2. So we're going to say that this polynomial has a degree 2. And the leading coefficient is going to be that 3 in the front. So when we write this in standard form, all the information that they could ask you about a polynomial is in the front. We call this a quadratic because the highest exponent is a 2. So anything that's looks like this or has a degree 2 is considered a quadratic. All right, same thing with a cubic function. We have a degree of 3, because that's the highest exponent here. And then our leading coefficient is going to be that 6 in the front. So anything with a degree 3 is going to be cubic. And then our last one, we're just going to, some of these, the higher you get, have actually specific names, but we're not going to get anything bigger than this. So we're just going to call it complex. So notice that this one has a degree 4. So we get to say this has a degree 4 polynomial here. And our leading coefficient, so even though it doesn't look like it has a number, remember there's an understood 1 here. So our leading coefficient can be 1. Also keep in mind your leading coefficient can also be a negative number. Just it happens that none of these numbers here were negative. So we're not going to spend a whole lot of time here, but since we're talking about polynomials, this is some really useful information to kind of already know. Just in case it comes up into when we're working problems or word problems and they're asking about degrees and leading coefficients of polynomials, or having to categorize them based on their name. All right, with that being said, let's go ahead and go into talking about what we can do to write polynomials in standard form. All right, so at the beginning of this video, we did kind of talk a little bit about standard form for polynomials. I'm just going to reiterate some of the stuff that I said. So a standard form for a polynomial, it arranges its terms in descending order of their exponents. So it has to do everything with their exponents. And that means that the exponents are going to go from the highest to the lowest degree. So let's go ahead and write that part in so we have it as a visual. So standard form arranges its terms from descending order of their exponents. So from the highest to the lowest or smallest degree. Okay. All right, so if we look at a couple examples here, we can see that we have 3 terms. So we have this negative 5a, we have this positive 2, and this negative 6x to the 3rd power. Now when we're looking at these numbers, please make sure that you know that the sign in front of that number actually belongs to that number. So sometimes we want to say, oh, that's a minus and that's a positive 6x to the 3rd, but not in this case. That negative, that minus is also considered the negative that belongs to the 6. So please keep in mind that you're not just looking here, but you're looking at what sign is in front of it. So what we're going to do here, and there is a typo here, so I'm going to go ahead and clarify that. This one has an A and this one has an X. So let's go ahead and change this to an X, because polynomials will have the same X variable in the expression. So I noticed that this X is raised to the 3rd power and this X is raised to the 1 power. So what I'm going to do is I'm going to rewrite it, and then I'm going to identify the degree and the leading coefficient. So we're going to say negative 6x to the 3rd. We don't have a 2nd power, so we're going to skip it and go to the negative 5x to the 1, or you can just put negative 5x. And since the 2 is our constant, it's a positive 2, so we're going to say plus 2. So for this one, we're going to say that the degree, the highest exponent is 3, and the leading coefficient, LC, is going to be negative 6. And there you go. That's all we're doing here. So if we look at the second one, so this is a cubic function because of degree 3. But let's look at the second one. Notice that we have nothing but x's here. The highest exponent here is a 2. So that one's going to go first. And remember, if you just have a variable with no exponent, it's an automatic one. So for this one, it's a positive 8x to the 2nd. Then comes the positive 5x minus 3. And for this one, we get to say that it has a degree of 2, which makes it a quadratic function. and then our leading coefficient is an 8. All right, the last one here, you're going to notice that we do have two x's, and it looks like we don't have exponents on either one. So that means that we can actually put these two together. So let me rearrange it first. We'll put them together and then simplify it. And then name the degree and the leading coefficient. So it doesn't matter what order we put these in because they both have the same number, the same degree. So I'm just going to put them next to each other like this. And when I realize that these are like terms, same variable, same exponent, I can actually put them together. So if I take -3 and add 5, it will give us a positive 2x plus 4. So now that I simplify it, I can see that the highest degree is 1. So it's a degree 1 polynomial, which means it is a linear function. Our leading coefficient is a 2. And there you go. So the most important thing right here on this front page is identifying and being able to rearrange those terms to where they're written in standard form. So all of our answers moving forward will need to be in standard form. Now I may or may not ask you to identify the degree, to give me the leading coefficient, or tell me the name of the polynomial, but just know that the front of this page kind of goes over that. So I'm actually going to pause right here, and then I will see you in the next video so we can actually do some simplifying of these polynomials. All right, I hope these examples and this conversation has helped you understand polynomials a little bit better.